Okay, solutions video 10, 9-station review, part 2. Write the balanced equation. Given the following reactants, indicate the state of each substance and circle any precipitates that form. Solutions of aluminum nitrate and lithium oxide. Aluminum 3+, nitrate is -1 if I can find it. Where are you, nitrate? There you are, NO3 minus. Okay. So aluminum nitrate, that's going to be, well, let's just write out the ions real quick. Aluminum is 3+, nitrate NO3 minus, lithium is +1, and oxide is -2. Those are all the ions that are going to be used in this reaction. Okay, so again, the goal here, whenever I'm writing these compounds out, is to cancel out these charges. So if I've got a 3+, I'm going to need 3 of these minuses to cancel that out, right? So Al NO3, and I need 3 of them. Now, something that I saw you guys doing, some of you guys were doing at least, and I had to stop you. Do not write out the charges anymore. Those charges are gone. Once these things combine, there are no more charges. They're done. Finished. So don't write them out. That's a no-no. You'll get points deducted for that. Aluminum nitrate and lithium oxide. Lithium is +1, oxide is -2. Lithium oxide, therefore, you're going to need 2 of these lithiums to cancel off that -2 charge. So Li2O. Okay, what's going to happen here? Double replacement's what's going to happen. It tells you right there. It's a double replacement. Switch out aluminum and lithium. So now we get aluminum, which is a 3+, and oxide, which is a 2-. So 3+ and 2-, that means 6 is going to be our common denominator. So we're going to need 2 of these and 3 of these. So Al2O3 plus lithium nitrate, +1, -1. So LiNO3. Now let's go ahead and balance, and then we'll talk about, well, these are solutions. We'll talk about the states here in a second. Let's balance them first. We've got 2 aluminums here, 1 here, and 2 there. We've got 3 nitrates here, and 1 there. And we've got 2 lithiums there, and 1 there, and 1 oxide, and 3. I'm actually going to solve this one off camera here, and then I'll come back to you because this one's a little tricky. Okay, I'll go ahead and show you my work, and I'll show you where I ran into trouble. If you start with the nitrates, you're going to run into trouble by putting 3 nitrates here. Okay, and the reason why is you end up with 3 lithiums and then on the right side and 2 on the left. So don't start with that. Instead, start with the, what did I start with? I believe I started with, I started with the aluminum, and I'll show you how this will go, okay? So you start with the aluminums. I've now got 2 aluminums on the right and 2 on the left. I've got 6 nitrates now. So 2 times 3 is 6. And if I put a 2 there, if I put a 6 here, I've now got 6 nitrates. Okay, no, that's not right. Well, yeah, it is. Yeah, it is. Never mind. 6. Okay, so I've got 6 nitrates. I've got 6 lithiums. And now I put a 3 there. I've got 6 lithiums on this side. And I've got 3 oxides on both sides. That's how you balance that one. So that's a tricky one. And again, I recommend you do it with a pencil. I did it off camera just because I knew I was going to have some problems, and I didn't want to waste too much time. Okay, let's go ahead and do the states that they're in. These are solutions, so that means they're aqueous. Aqueous. Okay. So now let's look and see on our solubility table if aluminum oxide forms a solid or not, if it forms a precipitate, and it does. So we can write solid. It formed a precipitate. Again, that's a 6 there. 6 LiNO3, lithium nitrates. And let's go to lithium. Everything in the lithium row is aqueous, so that's a solution. Okay. Next up, solutions of calcium hydroxide and sulfuric acid are mixed. Okay, so let's go ahead and write out our ions again. Calcium's 2+, hydroxide's OH-, sulfuric acid, well, that's H+, and SO4 2-. Okay, let's go ahead and write them out. Calcium hydroxide, CaOH2 plus H2SO4. Why H2? Because I've got +1 here, -2 here. Okay, H2SO4, and with calcium it's a +2, and the hydroxide's a -1. Okay, I did that kind of fast, just from memory. I forgot to stop and tell you guys what I was doing. Okay, calcium switches with the hydrogen. So you get calcium sulfate and HOH, which is water. So calcium sulfate, calcium 2+, sulfate 2-, CaSO4 plus H switches with the OH to form water, H2O. Let's look and see if it's balanced. Here we've got 2 hydroxides and 1 there, 2 hydrogens and 1 there. If we put a 2 in front, we should be balanced. We've got 1 calcium and 1 sulfate. Okay, so now that we're balanced, we know that they said these are solutions of aqueous. Okay, calcium sulfate. Let's go ahead and look on our solubility table. Calcium sulfate does in fact form a precipitate, so we can write an S there. And H2O is a liquid, it's a pure substance. There you have that. Station 3 done. Okay, station 4 is more of the same here. Solutions of lead nitrate and hydrochloric acid are combined. So lead nitrate. Let's see what we got for lead. Lead we're saying is a +2. And nitrate again is NO3-. So lead is Pb +2, nitrate NO3-. And hydrochloric acid is just H+ and Cl-. Okay, so look, lead nitrate +2, NO3 is -1, so I need 2 of these, right? So lead nitrate, Pb, NO3, 2 of them, plus hydrochloric acid, which is just HCl, yields. These guys are going to switch in a double replacement reaction. So you get HNO3. Actually, let's go ahead and do this. Pb, Cl, Cl2, right? Plus HNO3. That's interesting. HNO3. Okay. These are solutions. Oh, let's balance them first. We've got 2 nitrates here, 1 there. So let's go make that a 2. Now we've got 2 hydrogens here and 1 there. Make that a 2. Now we've got 2 chlorides here and 2 chlorides there. We are balanced. Let's go ahead and write an AQ down there. And that's nitric acid. That's really interesting. That's why I paused, because I saw that was one of the products, nitric acid. Interesting. Anyway, and lead chloride. So let's see what lead chloride that is. If lead chloride is solid, forms a precipitate. Okay. Interesting one. Using hydrochloric acid to make nitric acid. Very interesting. Okay, next up, I can only imagine this would be really nasty stuff. Really, really nasty stuff. Maybe found in a car battery, as I'm thinking about it. I don't know. No, not in a car battery. Anyway, solutions of magnesium acetate and water are combined. Magnesium acetate, so Mg2+, acetate C2H3O2-, and water H plus, OH minus. Broke it down into its ions. Okay, I had this one memorized. I think you should do the same. I would recommend it. Okay, let's go ahead and do it. Solutions of magnesium acetate. So I've got 2 of these. I need one. I'm sorry, that's a 2 plus. I need 2 of these to cancel out that 2 plus. So MgC2H3O2. I've got 2 of them. Plus HOH yields. These guys are going to switch. So I get H. How many of them do I need? 1 H to balance out the acetate. HC2H3O2, which is acetic acid, and magnesium hydroxide, MgOH2, because that's a +2 charge and a -1. Okay, so this is a solution of, that's aqueous, that's liquid water. This is acetic acid, so we know that this is soluble, aqueous. The next thing we have to do is figure out if this is soluble, magnesium hydroxide. So let's look. There's magnesium along with, where'd you go, hydroxide? There you are. Magnesium hydroxide forms a precipitate. Alright, and there you have that. That concludes video number 2.